Hi, I'm Kala Govindrajan, part of the solution innovation team at Snowflake. We develop innovative solutions for customers, partners, and everyone. Digital payments have become a cornerstone of modern e-commerce. From online shopping to mobile banking, the convenience of making transactions with a few taps or clicks has transformed the consumer behavior. Online platforms and mobile applications have made digital payment methods more accessible and convenient, leading to a significant increase in the volume of transactions conducted electronically. Now, I'm going to walk you through the code that we built to detect fraud in such transactions. And this code or this demo has been built on Snowflake notebooks, and it also leverages some of the other great capabilities of Snowflake, like Snowflake Feature Store, ML functions, and also Streamlit in Snowflake. Let's jump into the code. So welcome to the demo. We'll be walking through two notebooks and one Streamlit app. The Snowflake notebooks come with a ton of capabilities, and we are going to explore each of that capability as we run each cell here. Overall, in this demo, we are going to train a model using Snowflake ML functions for credit card fraud detection. We are going to set up the initial database objects, warehouses, and then we'll be setting up feature store entities, generating a data set from that, and consuming it in the other notebook. All the setup, grants, privileges would be covered in the first notebook. And let's dive in. The first cell that you see here is the import libraries, where you could go and pick which package you need as part of the setup. So for this notebook, for example, I would want to leverage Snowflake ML Python because I'm going to use some of my components from Feature Store, and that requires the ML Python library. Feature engineering is nothing but a process where raw data is transformed into features, and they can be used by this machine learning model, and it is a very vital part in building any machine learning application. So this feature store in Snowflake helps you easily create, find, and employ features that work with your data. So for leveraging the feature store capability, I'm using the Snowflake ML Python library. As you can see here, I had already imported this library. And if there are any other visualization libraries that's required, those can be imported from this Anaconda channel directly here. Let's go and start the notebook here. And what you see here is that as the notebook gets started, we can browse through each of the cell, and the notebook is already active. That's great. Now let's scroll down and we'll see each of the libraries that's being utilized. I'm using some of the Streamlit components downstream. So I would like to import the library, pandas, some window functions to generate new features. And also I'm using the get active session, which should help me get the context of the current session. So prior to creating this notebook, I would have passed a database object and a warehouse, and that's been obtained here from this get active session. Then we'll be moving on to instantiating a feature store. Using the Python SDK, we are going to define a feature store, Snowflake feature store, where you have the feature store, feature view entity, and the creation mode as the parameters that's passed here. Also, you can use import Snowflake login options if needed. You can leverage that. So I'm setting up the database context here. So for the simplicity of this, quick start or a quick demo that we are walking you through, I've used the sysadmin role, but in production, you would want to use a separate role that's been designated as a feature store or feature producer and feature consumer. So those can be two separate roles. I'm keeping it simple and using a sysadmin here, and I'm also creating a database called FinsDB, credit card FinsDB, and I'm using the database. I'm also creating a schema called analytics, and I'm creating a warehouse for this particular demo. After I finish that, as I mentioned before, you could use a separate role for a feature store producer and feature store consumer so that you have that entitlement or separation clearly specified. Now, these are pretty much declared here as variables, and that can be consumed a little bit later. And then what I'm doing is I'm creating a new feature store. What I'm by specifying my database and the schema, we could also configure a default warehouse and also the creation mode, whether if the feature store exists, whether you want to create it or fail if that doesn't exist. I'm setting the context. I want to make sure that's there, and I'm printing the context out here. And then starts the data ingestion process. So during data ingestion, what I want to do is I have my data hosted in a public S3 bucket, which I'm bringing in here. So I would like to refer to that URL, and I'm creating an external stage that's picking data from my S3, and it's of the format CSV. So I'm leveraging that, and I can see that the data is coming to the stage called credit card transactions. Now let's go and run this notebook, and I will slightly also walk through the features in Snowflake notebooks. You have different types of cells, like markdown cells where you can give some information about what's happening overall in each cell, etc. You also have the flexibility to switch between SQL and Python and leverage both capabilities. And also we are looking at the session code, instantiation, and everything. So let's go and run the first cell where the libraries get imported. And then I'm setting the context and then some variables that might be used, and also initiating the feature store after that. So I think I clicked too fast. So that's the variable setting process. And then I want to wait because I do not want to stop, which I did the prior. Okay, and here comes the place where I start the feature, instantiating the feature store. And then once that is done, I'm using those, I'm setting that, what is my role, database, and the schema. Let's print that, and then we'll move on to level, bringing in the data from the external stage and loading into my stage. So you see that the data has been mounted here, and it's available in the credit card transaction stage now. I want to read that data, read the CSV file from the Snowflake stage and create a Snowpack data frame from that, and then finally save it in a table called credit card transactions. And we can look at the data in a minute once this is processed. So you see that I have a lot of transaction details here, wherein a particular user in a session carried some transaction. What is the transaction amount he or she carried out? What is the date of the transaction? Which merchant did she carry the transaction at? Whether that has been classified as fraudulent or not? How many milliseconds did she spend on that particular website? Clicks. How many clicks was there before she ended up doing the transaction? How many logins per hour? Pages that she had visited? What is her credit card number? And from which location this was the transaction originated? So this is for one particular user. I can look at different users in a minute, but these are some crucial, important attributes that will help us help the model learn better. So this is more of a synthetic data that we generated for this demo purpose. This data has the rules to generate those patterns and behaviors to differentiate normal and fraudulent transactions. These patterns from the attributes is going to help the model learn. And we wouldn't stop there, but we would also need to help the model learn better by generating more features. And that's what we will be doing in the feature engineering, where it's a vital part of building a high quality machine learning application. And so we are going to take all these raw features and transform them. Now, when it comes to Snowflake ML functions, it does not have any limitation about whether the data has to be discrete or it can be, or it has to be continuous, etc. You can pass in categorical data, numerical data, and even Boolean. Snowflake is going to handle all these different types of data types for features and the labels. So coming to the feature engineering part, what I have here is the customer data. So I'm looking at the transactions, and I'm creating some features. I'm trying to understand what did my customers spend on a weekly basis, on a monthly basis, right, on yearly basis. And then I'm trying to generate those features and have them as create a data set out of that. So you see that for each user ID, we see the total number of transactions he or she carried in a physical year. What is the average transaction per transaction amount? Number of unique merchants, how many merchants do they generally visit over the physical year? How much do they spend weekly, in a monthly, or in a yearly fashion? So this helps the model train and learn better about what a customer does in a normal time, and when a fraudulent activity happens, how does this features look like. Similarly, with that, after generating the customer related features, I'm going to now go in and create a data frame. So if you look at this, I had created the customer generated features. I give a name here. I can use the cell name and directly convert it into a data frame using the 2DF method. And now I have a Snowpark data frame. Pretty cool. So once I take this data frame and I want to save it as a table so that I can look at it at different point of time. So I have this customer as a data frame where which has been saved to a table as well right now. And you can see that the data is right here. Now, what I want to do is do a similar activity for my transactions, where I'm going to generate some cumulative metrics around my transactions itself. So what happened when a particular transaction was carried? How many clicks did someone do? Where did the transaction originate from? What was the total number of clicks or time elapsed, etc. So these would give a lot of transaction related information, and also the behavior of fraudulent transaction versus normal transactions. Now, again, like I did before, I'm using the generate transaction features cell name. Directly, I'm referencing that cell and converting that into a data frame. So now I have a data frame transdf, and that's going to be written into a separate table. So that's what you see here. And then moving on to to the feature store part. So the feature store is feature store objects generally map directly to schema objects, Snowflake objects. Now you can think of the feature store itself as a schema. The feature view that we'll be looking in a minute is a dynamic table with internal features, or it can be a view with external features. The feature entity for a customer, I create a separate entity. For the transaction related features, I create a separate entity. That would be like a Snowflake tag that would be mapped to a tag from a Snowflake object perspective. And the feature itself is a column in a dynamic table within Snowflake. So once I have generated the data that's required to go into these feature entities, these entities are nothing but the underlying objects that features and features views are going to be associated with. They have a join key. So for example, in my customer entity, my join key is going to be nothing but my user ID. For my transaction entity, my join key is going to be nothing but the transaction ID. So it's more of like, imagine imagine a table with keys, right? And you also have the concept of the schema, this warehouse, which is based on star schema, where you have a central fact table and a lot entities around the dimensional tables. So think of these entities as dimensions, and we are going to look at what is the fact in the next notebook. So let me just give you can use a delete entity to delete any existing ones. Let me give a new name, so that you would want to do this. You want to capture how your features looked at different points of time and maintain that particular hierarchy or history. So I have registered these features. And now what I want to do is I can see I have a lot of other features as well. Now I can also give some description so that I know that, okay, this trans ID was created. Trans ID new was created for the demo purpose. Trans ID was created during, transactions when holidays season was there and a lot of transactions happened. The patterns look differently. And similarly, right? So I can give a meaningful name, carry a description here so that I can use those versions of feature views when I train the model. So what I'm doing here is I can give a new version here. I'm creating a feature view. A feature view is nothing but a logical entity, a logical structure again. And it is a group of logically related features that are refreshed on the same schedule. Think of this being a real-time pipeline. New features come in, new data come in, so new features are harvested. So the feature view constructor contains the feature generation logic, and it also contains a join key. So I have my customer entity, and I'm creating a customer feature view that's getting data from customer as data frame, and I'm giving a version for this, and I'm registering it to the schema. So that is what is happening right here. Similarly, we would be doing the similar thing for my transaction features itself. So here in this notebook, what we have seen is we have set up a couple of database objects. We have also looked at what the feature store producer workflow. Now, classification or the Snowflake from Snowflake ML function, which is the function that we are going to use for training this fraud detection model, requires privileges. To be, the role to have special privileges. We'll be looking at those privileges and how you could separate ML admin, ML consumer, more on the same lines as that of the feature store, where you have a feature store producer, feature store consumer roles. You could have those roles separated. For simplicity, again, I have leveraged sysadmin here. So that so it's more direct and straightforward. And we have produced the features, we have ingested the data, and we are ready to consume these features for building the model for the binary classification. So let's move on to the second notebook here. My notebook is already active, so I don't need to start it again. In this notebook, what we are going to do is we are going to do some exploration. We are going to do training, and then we are going to do some prediction on the validation data set. If you look at this particular cell, it says we need a couple of more packages in addition to Snowflake ML Python. So I need Snowflake ML Python for the feature store again, because I'm going to consume the features that I had produced in my first notebook. In addition to that, I'm using matplotlib and Seaborn, some of the visualization libraries, because I want to do some exploration in the beginning. So I first step is to import the libraries, getting the context, and some visualization parameters have been set up here in the beginning. Now I go and use the same role, same database and schema, because my database is stored in this, my data is stored in this database schema, and I want to use this role consistently throughout. Now remember I talked about the fact and the dimensions in the first notebook. So we have created the dimensions, but we do not have the fact. The fact is nothing but the spine data frame. The spine DF is where you will have the all the facts present. So what transaction happened and which user did the transaction, and that's going to be the spine data frame. So I create a table just for the spine data frame, and I'm going to join that fact with my dimensions. So which is nothing but the different feature views would be consumed here, and a new data set, Snowflake data set object would be created using by integrating the spine DF along with the facts. So generating tables for training can be done using the feature stores generate training dataset. This enriches the Snowpark data frame, right, that contains the source data with the derived feature values. And you can also one can just slice on a particular timestamp as well and get that point of time, and look at that data there and just use that as well. It all depends on the use case. For this demo, we are going to leverage all the data, and the generate training data set is the signature, is the method that we will be using. And the Snowflake data set is an immutable file-based snapshot of the data, and we are going to use that for training and giving that as an input to the ML function. So we have created the spine data frame, and now we can take a look at. We will be creating and storing that in a table as well. We'll be looking at some data exploration, looking at stats. How does my data look? I have around 100K records here, and the transactions vary from different time period and different merchants, and what's the general statistics about this. And then what are the different attributes or columns that I have here. And then I'm going to look at how much fraudulent transaction here is present. So it's a basic bar chart that is leveraging Streamlit component, as you can see. And you do not need any other visualization libraries. These basic charts can be generally pulled up for using a Streamlit library itself on a Snowpark data frame if needed as well. So if you look at this, I have a 80-20 kind of split almost, where 20% or 17% of my transactions seem to be fraudulent. So 0 is normal and 1 is fraud. And then I'm also creating some histograms to see how is my different attributes playing here. So if you look at this, my normal transactions seem to be all lying under $1,000, while my fraudulent transactions, they tend to move to a different range. So if you look at this, their frequencies or their amount goes high. And if you look at the clicks as well, the normal transactions, generally the clicks are like, you start browsing and you passively keep looking, and then when you add to a cart and you want to finish, you go up a little bit higher on the clicks and finish it off. But in the case of a fraudulent transaction, the clicks are either too fast, they do not want to spend much time, but they want to finish it off and come out. The logins as well is seen here. Similarly, a distribution about how much time someone spends there in terms of seconds. And finally, the geographical location. So if you look at the normal transactions, it is towards a place where the consumer resides. The fraudulent transaction is seen to originate from totally different geography, some other part of the world. So this is some basic exploration that was carried, and then we are looking at the feature store. Again, we want to use the same version of the feature view that we had created in the other notebook. So I'm instantiating this feature store and telling that, okay, I want to now consume these feature views, right? These features and enrich my spine DF, which is nothing but my transaction table. I'm going to enrich it with my customer and transaction features. I'm going to split the data for training and validation and store it in a separate data frames. And while that happens, we'll also walk through the training data set. So when you look at the training data set, that we have the all the attributes, all the columns here. It can be, like as mentioned, it can be Boolean, categorical, discrete or continuous, in terms of numerical, anything, right? So all these are here. I want to make sure that I remove some of them, like IDs, and I just select only ones that is required. All these attributes would be required. Is fraud would be called as a label, so it is not going to use is fraud for training. In the validation data frame, I'm going to drop the is fraud, and you don't have to actually specify what other columns you need, because validation data frame will by default take the other columns that was used in training. So it will do a mapping of the name and take it. So now it's time to actually move on. And I'm also creating a temp table that I would be using during the fraud detection app. So let's create that. And then I'm going to move on and have all now that my training and validation views, everything has been created, I want to go and build the model. So what you see here is the classification model. The classification model is powered by the gradient boosting machine. We are going to do a binary classification. And for this, the model is trained using, how much area under the curve, right? That loss function is being used. You can also do multi-class classification, for which the logistic loss function would be determined. So it would get trained until that particular loss function decreases, right? This particular classification model can be also evaluated for the quality of the prediction. So there are some metrics that we'll be looking at later. So in terms of the classification model, what is required is a virtual warehouse and the grant privilege required to create this classification model. So create Snowflake ML classification privilege on the schema is required. And other regular privileges like create table, create view, etc. Because we have been doing that so far. All that is required, and so that there is the right grants is required, and these privileges needs to be granted to a custom role if you happen to choose that, or sysadmin by default has most of these. You can also choose a warehouse. You do not have you always have to choose a large warehouse Excel only if you are if you think that the training is taking a long time for million rows, and there is a limit on how many million rows that can be trained. So if you think that it's being too slow, then you can bump up the warehouse, but you can stay within a smaller warehouse size as well. So I use the create Snowflake ML classification to create and train the model. I'm giving it my classification training view that I created earlier. I'm telling that is fraud is my label column. So use this and get trained. So that is what you see here. So we'll give it a few seconds for that to complete training. And you can see once that is completed, you can say show ML classification, and you can look at what the model that has been trained and what is the version of that. Apart from show class, now that the instance has been created, let's go and look at ML classification, and you see that this model object that I just trained has come in. Now I can also run inference or prediction on the data set using the predict method. So the model's predict method, you can just call the predict method on the name of the model itself. So the name of the model is fraud classification model, and I'm using the predict method here. My input is nothing but the validation data frame, and you will see the output with the probability and the class coming out. So as you see here, I had given my all these users transactions, and I wanted the model to predict. If you look at the last, there's a new column called predictions that has come here. If you look at this, you'll and please focus on the probability field in this JSON. You'll see that the probability of this transaction being 0, which is normal, is 9.99, while as the probability of this being 1, which is fraudulent, is 7.9. Now it takes which is the higher of these two, and it gives back what is the class. So 0 seems to be of a higher probability. And I'm going to, and it returns B back that this is probably a normal transaction with a, so similarly, you can see some, few of them are, with a higher probability of 1. And that's what we can do is we can parse this out, right? And nicely display this JSON, and then we can go into the metrics after this. So if you look at this, I have my class, I have the probability with which, of course, this has been rounded up, but the probability with which the model predicted whether this transaction was or is fraudulent or normal. So now I have created the model, trained the model using the training data set. Now we look at the different metrics that's being used. So Snowflake provides these metrics through this model name and show metric method. If you call it directly over the model, you are going to see different measurements or the values, how well the model performed. So the first one would be the confusion matrix, and it's a table generally to assess the performance of the model by comparing predicted and actual values, false positive, false negative, true positive, and true negative. And we see that the score seems to be very high here. Similarly, if you look at the show evaluation metrics, where in my evaluation metrics, I can look at the precision, recall, and F1 score. We can leave the accuracy because this is more on classification, and we want to see, how much is my precision overall. And and the logs can also be enabled. It's a separate parameter, and you can look at the logs as well. Similarly, you can look at the threshold metrics, which provides the raw count and the metrics for a specific threshold for each class. And then finally, we can look at the feature importance. So what it is generally nothing but the approximate ranking of the features by the trained model. It counts the number of times each of the model tree used each feature or each of this feature to make a decision. So looks like time elapsed, how much time someone took to make place a transaction, the longitude, how many transactions someone would have done, and of course the latitude and cumulative clicks. All these have been helpful to help the model and train. What has helped the model train, and that's this chart. And this completes actually the end-to-end of this notebook, where we consumed the features from a feature store, enriched a spine data frame for transactions, and then we we generated the final training and validation data set. We trained a Snowflake ML classification model using this supervised data set. And then we also did a prediction on a validation data and looked at the different metrics. Now it's time to head to the Streamlit app. This app is nothing, this app was built to, as a part of the, to show the overall ongoing inference for new transactions. So this will deliver more. This can be thought of as a fraud detection app. So tomorrow when end users want to come and determine what transaction or which transactions might have been fraud of in the of what has come in the pipeline, they can come to this app, and just on the click of the button, they can predict the transactions. So you see here that some transactions have arrived, and looks like these new transactions that are coming needs to be determined whether they are fraudulent or normal. So what is happening in the back end is, like, when I click predict fraudulent transactions, what's happening is the trained model predict method is being called, and this data is being passed to that model, and the output, whether each of this is fraudulent or not, is given back. We are also displaying this in a geospatial. We want to do it. Want to perform a geospatial analysis, and we are displaying the origination of the transactions. And if you look at these transactions, that's lying a little apart from where the customer location is, it looks like they are fraudulent. And if you look at transactions that are originated from the customer's area, most of them are normal. And that's you can determine from the color coding as well. And finally, I see this output of the transactions that came in, and what is the what is the class, whether they are fraud or normal transaction. Now I also have some charts that helps me understand. Okay, some merchants seems to have some fraudulent transaction seems to originate from some of these merchants. And what are the transactions amount, like we analyzed earlier. So what is the time elapsed during each of this kind of nature of transaction, and the number of clicks. So that brings us to the end of this demo. I hope you all learned how you could easily leverage, whether it's an analyst person or a data scientist person or anyone, easily leverage Snowflake ML functions, leverage Snowflake feature store, build everything end to end within Snowflake notebooks itself, inside Snowflake notebooks, and do not have to go outside of the Snowside UI itself, but stay within and take leverage of these cool capabilities. So we have built a classification model to carry credit card fraud detection, and in a Streamlit app that carries geospatial analysis. This powerful application could help financial customers and quickly understand fraudulent patterns and respond to it. And these automated predictions and data insights using the ML classification function. This data also doesn't need to be in time series as well, and that's more cool thing about this model. You can implement this end-to-end pipeline very easily within Snowflake boundary. Thank you.